part 4 of how to design a continuous flow intersection. I hope you enjoy it. This is the last part. What I'm showing here right now is I'm showing a green wave that corresponds with the phasing that's occurring with the simulation on the right. Okay, so if you look at the left-hand side, this green wave that's coming across that I'm animating, and it should be in synchronization, but this was a little challenging here in Keynote on my Mac computer, but I'm trying to show exactly when the phases are occurring with what we just designed exactly. So you'll see right now phases 9 turning on with phases 4 and 8, and then you're going to see phase 9 shut off now and phase 10 start. Okay, and you may want to rewind this and watch this a few times if you are looking on CFI designs. I think it's very helpful just to see how it's operating, and here it's going to end, just repeat the simulation cycle. So hopefully this slide would be very helpful to the traffic engineers working on CFI designs. What traffic signal controller software and hardware do you want to use? First, only use one controller. They need to be coordinated and sync at all times. I've heard people operating like master-slave combinations, using separate controllers at each one. If you decide to go with the CFI traffic signal, use one controller. I know it's going to be a maintenance issue when you have your technicians go out there. Like, how do you look at all the signal heads at the same time? I don't think there's any way around it. But when you do go with the CFI, go with one controller and understand that there's going to be certain maintenance issues that you're going to encounter with your technicians and how they're going to have to learn how to operate it. You can operate on most current traffic signal controller software. Use an example, kind of like ASC3s now. You know, most software operate, you got 4 rings, 16 phases. Based on the phasing I'm showing here, most standard controllers can operate it. If you need to go to a more advanced software like next phase, they are available. I don't know how it impacts your coordination with other signals, but there are software packages. I don't think it's a question of is the software available. It is. It's just a matter of which one you use. Pedestrian overlaps between phases 2 and 6 and 11, you could look at as being possible. I did not talk about pedestrians here in this presentation. It is something that one has to evaluate closely. I know that there's a study out there that talks about how CFIs are safer from a pedestrian standpoint, but when you start looking at pedestrians and you look at the time it takes to cross all these lanes, and you're looking at 3.5 feet per second per pedestrian, you get long pedestrian times. And it may vary by software on if you can overlap those pedestrian phases with a few different phases in order to reduce it, or are you going to put the pedestrian phase in here, and like as I'm showing only in phases 2 and 6 maybe, and you're just going to really disrupt the system. So think about how you're going to do pedestrians with overlaps and what software you want to use. Number of load bays and controller cabinet needs to be evaluated closely. Need for approach monitoring, depending on how your organization looks at it. Do you want to combine multiple phases? Like, you could combine phases 4 and 8 here, no problem. But do you want to? Do you want to have approach monitoring? Look in the cabinet to make sure you're going to have enough. You could go with an ITS cabinet, like for the one at Miami Township. Though they did decide to go with an ITS cabinet. And I believe there's going to be 28 load bays available, and it's not following a typical, let's say, CFI phasing as I'm showing here. It's a little bit more complicated, but I don't think you're going to have too much problem if you use a 16 load bay cabinet, but you need to make sure that it's going to work. You use a UPS battery backup. I'm hoping most agencies are using them now with new traffic signal installations, but especially with this installation. This installation goes on flash. You know, I haven't seen it operate, but I think it could be pretty complex, and I think law enforcement would have a hard time directing traffic in this type of operation. So you use a UPS battery backup if you're going to go through one of these designs, and there's solutions out there. They exist for all parents and areas that I could think of, and like I indicated, you could go with an ITS cabinet approach. Here I'm just adding the phases over time. So in summary, CFI can be designed following existing traffic signal design procedures. I don't think you have to depend on simulation totally in order to come up with these designs. I know some designers have looked at it that way. I think there is a step-by-step methodology. Design it with supporting calculations that can be prepared. And hopefully I was able to communicate that with this presentation. If you are working on a CFI design and you need some help, don't hesitate to email me at gary@garyshoop.com. I'll do my best as possible. Hopefully I'll have some more videos on CFIs once the one in Miami Township gets up and running. Please do leave comments on YouTube if you have watched the video. Has this been helpful to you? Will more similar videos be helpful to you? I'd be glad to work on them. I thought about preparing a paper on CFIs. I decided against it from the standpoint this was pretty technical, and it's a very small audience, and much easier to get out and open to the public if I approach it on YouTube, and I think it actually be shared among more people. I previously put a YouTube presentation on signal loop construction, and it's actually had a pretty big international following. Why, I don't know exactly, but I'm kind of hoping that this actually is opened up to internationally more so than if I put it into a trade publication that focused in the United States. So thank you very much. Hope the presentation has been helpful. Any questions, please send me an email. Take care.